Hello, let's talk about vectors. A vector is any quantity that has a magnitude and a direction. Magnitude being the size of a vector and the direction being where a vector points. We represent vectors visually as arrows, which have a size, a magnitude, and the direction, the way the vector points. We use vectors a lot in physics, especially graphically, to represent stuff. And there's a specific type of vector we will be talking about today called a position vector. A position vector is a vector that points to the location of something. If we were to have a graph with an origin, here's the origin of our graph. Here's the y-axis, the x-axis. And we can have things at different locations in our graph, like this board. Our board could be at the coordinate 1, 2, 1, 2, 3. So our board is at 2, 3. The position vector of our board at 2, 3 will be a vector that starts at the origin and points to the location of our board. So right here is our R position vector. We can write out our position vector as R vector equals the x component in the x direction, where x hat represents the x direction, plus the y component in the y direction, where y hat points in the direction of y. You might also see different notations for our R vector. It might be the x component times I hat plus the y component times j hat, where I hat means the x direction and j hat means the y direction. You might also see E sub x hat plus E sub y hat as another notation representing direction. I'm just going to use x hat, y hat, and later z hat in these videos for simplicity, and that's the form I'm most comfortable with, but you could also see I hat, j hat, or this E sub x, E sub y hat. Here, our position vector will be equal to 2 x hat, 2 in the x direction, plus 3 y hat, 3 in the y direction. This right here is our position vector. There's another type of vector called a unit vector. A unit vector is any vector that has a magnitude of 1 unit. Unit meaning 1. Unit vector. A unit vector would be u hat. The magnitude of a unit vector is 1. We use this hat, this pointy thing above the letter, to mean unit, which might make you think, wait, we see that over here in our position vector. There's a hat over the x and a hat over the y, which I told you represents the x direction and y direction. Are x hat and y hat also vectors? They are. They're unit vectors. So x hat is a vector in the x direction that has the size of 1. X hat. X hat just means 1 in the x direction. Y hat is a vector in the y direction that has size of 1. Y hat. Our position vector, R vector, can be represented by the unit vectors of x and y. R here is equal to 2 x hats. It's the x direction twice, so 2 x hat. And y is represented by 3 in the y hat direction. So we simply have 3 y hats, or rather 3 y hat. two x unit vectors, three y unit vectors, add them together, and you get our position vector. And that's what x hat and y hat mean. They're just unit vectors, vectors with the size of 1. X hat is in the x direction, y hat is in the y direction. Now we can have unit vectors point in any direction we want. We could have a unit vector pointing in negative y direction. So a unit vector going down would just be minus y hat. A unit vector to the left will be minus x hat. We can even have unit vectors point in directions that are on x and y. We could have a unit vector on r hat. How will we find this? Well, the size of our unit vector turns out to be always equal to 1. There's an equation we can use to find a unit vector in the direction of any position vector. R hat, the unit vector in the direction of r, is equal to r vector times 1 over the magnitude of r, where the magnitude of r is the size of the vector, is the length of the vector. The magnitude of r is equal to the square root of x component squared plus the y component squared, which you might recognize as the Pythagorean theorem, where c is equal to the square root of a squared plus b squared. That's what we're doing here. Our components in the x direction plus our component in the y direction makes a triangle, a right triangle, with our position vector. So we can use Pythagorean theorem to find the length, the magnitude of our r position vector. So our magnitude of r is equal to the x component, 2 squared, plus the y component, 3 squared. This is equal to the square root of 4 plus 9, which is the same as the square root of 13. Our unit vector in the r direction, r hat, will be equal to 2x hat plus 3y hat. The quantity of that times 1 over the magnitude of r vector, which is the square root of 13. We can distribute this guy, and we get r hat is equal to 2 root 13 in the x direction plus 3 root 13 in the y direction. And that is how we get a unit vector in the direction of a position vector. We can check this math by just finding the magnitude of r hat. Let's do that. Magnitude of r hat is equal to the square root of the x component, 2 over root 13 squared, plus the y component, 3 over root 13 squared. This is equal to the square root of 4 over 13 plus 9 over 13, which is going to be equal to the square root of 13 over 13. 4 plus 9 is 13. Keep the bottom, which is just the square root of 1, which is equal to 1. The magnitude of r hat is 1. And that is our introduction to vectors. A position vector is any vector that points to the position of something from the origin. Here's our position vector from the origin pointing to our board. A unit vector is any vector with the size of 1, where our directional unit vectors are x hat, a vector that points with 1 unit over in the x direction, and y hat, a vector that points 1 up in the y direction. We can find the unit vector of a position vector by multiplying the position vector by 1 over the magnitude of the vector. We can find the magnitude of a vector by taking the square root of the sum of the components of the vector squared. Now, next time we'll talk about vector addition and vector subtraction, and then we're going to get into 3D vectors.